so here we go. Section 8.2, which really is just an extension of 8.1. So I really don't think this will take too long. And I want to begin with a couple of facts on the board here. So why don't we simplify a couple of fractions being divided? So let's say we go 1/2 divided by square root 3/2. So this here could be rewritten as 1/2. Now instead of division, let's go multiplication. Let's multiply by the reciprocal of the bottom, which would be that there. All right. And then we can see that the 2's knock out, right? The 2's are gone, so you're left with 1/square root 3. Now, I'm willing to accept that, but you know how in your textbook, sometimes they're kind of picky. Maybe they would require that you rationalize the denominator, which is shown here by this red step. And that would give you a final result of square root 3 in the top and just an ordinary 3 in the bottom, right? Now, I want to do this same situation again, but backwards, like this. Look, now let's do the same numbers, but divided in the sort of opposite direction. So here, this would go square root 3/2 multiplication, but then we flip the bottom fraction and the 2's cancel. And here we just get, just a basic square root 3. So these numbers will pop up again for sure in just a moment. For now, I wanted you to see that when you divide these two fractions in that order, you get this. But when you divide these two fractions in that order, you get that. All right? So that's just a warm-up. Now let's go into some of the facts found in this section here, 8.2. Maybe I can jot them down over here. So here are some facts. And let me take a look at the camera, make sure it reaches over there. It looks like it does. So here are some facts, okay? So this is from 8.1. So in sine theta equals A, comma, remember that equation from the other day? Sine of theta equals some number A. If this happens, if you have sine of theta equals A, then we know that theta has to be within a certain window. So in sine theta equals A, theta is between, and what was it the other day that we said? If we're dealing with sine, like an equation with sine, then the angle theta, the answer if you will, it has to be between -pi/2 and +pi/2. And visually, we said that the answer has to be within this window, right? Somewhere within that window has to be your answer to the equation that has sine. Right? But that's for sine. Now today, we're going to open up the rules for cosine and for tangent. So similarly, over here on this side, we can jot down this other fact. We can say in cosine of theta equals A, right? A different situation now. So when you're dealing with cosine, that answer, theta is between 0 and 1 pi. So visually, for that one there, your answer theta would have to be somewhere in quadrants 1 and 2. Somewhere between 0 and pi. And I mean, when I say between, I mean like between, but also including 0 and including pi. And the same for this guy here, right? We can include those two sort of endpoints. So that's for sine and cosine. Let's write down now the rule for tangent, and then we'll spend the rest of this time doing examples after examples after examples. So now for tangent. In the situation where tangent of theta equals A, we say that theta is between -pi/2 and pi/2. So that situation is exactly like the situation with sine. So when you're dealing with tangent, then your angle theta, your solution, we want it to be between negative pi over 2 and positive pi over 2. So with those facts in mind, let's just spend now the rest of our time here in this video doing a bunch of practice problems, and then we'll assign the homework, like evaluate. And for example A, let's get warmed up here. Let's begin with a sine inverse. Just like that. So let me get out of the way, make sure you guys can see it. Make sure my camera's still recording here. When I see an expression like that, if it goes inverse, if it's sine inverse or cosine inverse or tangent inverse of whatever's in the parentheses, what I automatically do, just as a reflex, is I say, okay, I'm gonna let this equal some angle theta. That's what I do, right? And now what I'm gonna do is take the sine of both sides of this equation. Let's take the sine of the left and let's take the sine of the right. So let's go sine here. Let's go sine there. Right? We know these cancel. That's the whole point. So we get negative square root 3 over 2 equals sine theta. And then we can switch the order of the equation. So we have sine theta equals that there. And then that's when we recall our fundamentals here. We know that sine on the unit circle, sine is the y-coordinate. And we want the y-coordinate to be this number. So what you have to do is look at your unit circle and decide where on the unit circle your y-coordinate is this number. So if you look carefully on the unit circle, look for a y-coordinate that says this here. I believe you'll find that in two locations. I believe you'll find it here, and I believe you'll find it there. But we remember from last week that our answers to sine inverse can only be within there and can only be within there. And so for that reason, we throw this option away, and this is going to be our answer. And so you look on the unit circle, and down there, you look for the name of that location. And I believe on your unit circle, it would be like, I want to say it's 5 pi over 3. But then we remember that that's not within the appropriate window. So a different name for 5 pi over 3 is negative pi over 3. And that would represent theta. And that would represent your final answer, right? It has to be something between negative pi over 2 and positive pi over 2. So that was like last week. Now let's do an example using today's new stuff. So how about example B now? Cosine inverse, here we go. Cosine inverse, let's go cosine inverse of, how about negative square root 2 over 2? And then for this problem, we can take the cosine of both sides. So we'll take the cosine of the left, and we'll take the cosine of the right, because these knock out. And then we have essentially cosine of theta equals negative square root 2 over 2. And that's when you go unit circle, and you look at all the locations where cosine, or AKA the x-coordinate, we want the x-coordinate to be that number. And that happens here and also there. But we don't want to give them both locations. They don't necessarily work. What does work for cosine inverse is anything within that half revolution. So this one's no good, and this one's legit, and the name there is, I believe, 3 pi over 4, which is in the appropriate window between 0 and pi. And basically, you don't have to rename it any special name. It's within the appropriate window. Final answer. So that one there, to evaluate this, you do all that. Final answer, right? Final answer. How about this one? How about tangent inverse? How about tangent inverse of, let's say, +1? Now let's do a tangent inverse. So we have tangent inverse of 1, and then we can go tangent of both sides. We can go tangent. We can go tangent, right? Because we know these are gone. Bye-bye, bye-bye. So we have tangent of theta equals 1. Okay, and then we're like, how do we construct tangent? You know, tangent on the unit circle, the shortcut we established not too long ago was that tangent is y divided by x. We know that tangent is the y coordinate divided by the x coordinate. Well, look here. If it's 1, then that means that the top and bottom have to be the same number, because the same number divided by itself is pretty much always going to be 1. So on your unit circle, where does that happen? Where the x and y coordinate are not only the same number, but also the same sign. That would work here, and that would work there. Because here they're the same number, and so is here. But this one doesn't work, because for tangent inverse, we recall that it has to be within this span, this window. So this one's no good. That's the only option, and I believe that would be pi/4, and that would represent our angle theta. Right? Tangent inverse of negative √3. There we go. This one will make us think a little bit, okay? Tangent inverse of negative √3. We're going to let this equal some angle theta. And then we go tangent of both sides. Right? We go tangent of both sides. Bye-bye, bye-bye. And so we have tangent theta. We have tangent of theta equals negative √3. And then again, we recall that tangent is y/x. Recall that we said like 1/2 over √3/2 is the same as like √3/3. And then the other fact was that √3/2 over 1/2 equals √3. And that is like so relevant, because right now we see that we have a √3 and a √3. So let me just remove this because it's not relevant for this problem. Here is a fact. I know that this divided by this is that, and this is kind of the same thing. We'll deal with the negative in a moment. Don't worry about that. For now, I know that this is going to be my y coordinate, and this is going to be my x coordinate, because tangent is y/x, and this is y and this is x. And if I divide these, I get this back, which is like this. So my question to you is, where on the unit circle are we? Where? Where on this unit circle, specifically in quadrants 1 and 4, like that, because this is tangent inverse, where are we? Where is there a point where this is the y and this is the x? And if anything, what you can do to really make this clear is open up a parentheses, where the x coordinate is what it should be, and the y coordinate is that there. So where is 1/2 comma √3/2? It would be like right here, right? But I think it would also work there. And if anything, I think we have to be down here, because in quadrant 1, everything's positive. And if the answer is negative, it cannot be in quadrant 1. It has to be in quadrant 4. And if anything, it would be like a positive x coordinate and a negative y coordinate. So it doesn't really matter which one of these is negative, because if either of these is negative, it makes this number negative, which is appropriate. So this is the location that works, because the coordinates here would be like that there. And if you divide these two fractions, you get the goal. And now here, the question is, what is this angle, right? That angle there would be like negative pi/3, right? That would be that one there. So for sure, I think that one that has a tangent inverse with like a weird square root, that one's probably the more tougher one. It requires more thinking. And that's why we have homework. So what I want to do now is when this video's over, is I'll go to my computer and I'll upload or I'll update the homework, and it'll include a handful of questions, maybe like 5 or 6 questions, that does this here. And then on Wednesday, We'll spend the whole session reviewing for your midterm. Maybe I'll pass out like some practice tests from the past or something like that. So have a great evening, everyone, and I'll see you all on Wednesday. Take care.